with me is Neelu, and I hope Neelu is somewhere here. Actually, she should have been the one to make a presentation anyway, because she just submitted a thesis on the Arctic. So I won't take away much of my time in describing, giving a general introduction. What I want to do over the next 6 to 7 minutes is to try and answer 2 questions about Arctic. Question number 1, how significant is Svalbard as regards the short-term climate variabilities of a seasonal, annual, or even sub-decadal scale spread over the last 25 years or so. I'm not going back in time, it's only just the last 25 years or so. And second question, which is almost a corollary to the first one, is that is there any other place in the Arctic where we can look at the sensitivity of the climate change? Or is Svalbard the only place? I think the answer is fairly straightforward. Maybe not. Svalbard is the place, as I would like to explain over the next few slides. One, this of course, Nalan mentioned about it rather in our presentation yesterday. What you see here is that SaGHAA snow water ice permafrost over the Arctic report of 2017. It says that Arctic climate is shifting to new state. Yes, absolutely, everybody agrees that it is changing. And 3 things about the change are of fundamental importance. Number 1, it is becoming warmer. We have been listening to a lot of presentations since yesterday. It is becoming warmer, no question about it. It is becoming wetter. Yesterday there was a presentation, I think, who was the person who made a presentation saying that about the liquid precipitation in the Arctic is assuming significant proportion as compared to the snow. So it is becoming wetter. And the third and the most important thing which is a matter of concern is that the climate is becoming more variable, both in terms of amplitude and frequency. So that is the one thing which I would like to concentrate on. And here you have got the graph which shows about Arctic surface temperature, temperatures over Arctic. This is an anomaly actually. Basically it's an anomaly map which shows the temperature anomaly between 1900 to 2016 and normalized to the last 30 years, 1981 to 2010, which is the satellite era. What you see here in blue is the temperature, surface air temperature of the Arctic, and what you see in the red are the global average temperature. The most important thing is that leaving aside this hump, what you can see is the short-term climate variability spread over the last 10 years or so. Arctic is in fact really warming. And we reach about 2016 or so, what you see is that the temperature differences are order of about 2 degrees Celsius compared to the global mean, which really is something which is remarkable. And because of this warming, either it's brought about, as Nalan mentioned there the other day, I liked it, either because it's something which is acting from the top, Arctic warm air is responsible for the sea ice extended variability, or is it the transportation of the heat through the ocean medium which is responsible for the loss of sea ice. But whatever it be, the bottom line is that sea ice has been declining over the last decade or so. And not only is it declining, there's a pattern to that. This is the one which shows about Arctic sea ice over the last 30 years or so. What you see in brown, the brown line in the middle is the mean over the last 30 years. But what is striking here is that 2017 March is the time when you usually have the maximum sea ice extent, and September 15th or so when you have the minimum sea ice extent. Here what you see is that March of 2017, the max sea ice extent was on the order of about 1.22 million kilometers less as compared to the mean of the last 30 years. And the same is true of when you come to September of this year, 2017 September, again there has been an anomalous change. You see the sea ice extent in September 2017 is much lower than what was over the last 30 years. And 2012 is again an anomaly. We had a minimum sea ice extent in 2012. So this is a pattern which is getting reflected all over. It is variable. The sea ice extent is varying over a period of time. And this graph again, now showed yesterday, it's although despite the variability, the most important thing which you can see is that there is a general decreasing trend in sea ice extent over the last 20 years or so. And it's decreasing at the rate of almost about 13.2% per decade. which is not a small number. If you look at the size of the Arctic and everything, decrease of sea ice section to 13.2% is something which I would say it's a bit alarming. Now, what exactly are the factors which will have caused this so-called climate variability over the last 20 years? The usual culprits, people talk about the greenhouse gases. And then there is also the problem of black carbon. Today also there was a talk in the morning about this black carbon in Himalayan area also, which is responsible for the so-called warming which you observe. IPCC report makes it very clear. It says that decline in the Arctic sea ice appears to be largely but not wholly due to greenhouse gas. So they say there can be, so this is interesting, superposed on a natural climate variability spread over the last 30 years or so. It could be multi-decadal, it could be decadal, it could be much less than that. Superposed on this climate variability is the so-called forcing on account of the greenhouse gas, enhanced greenhouse gas emissions. What you see about is here is the carbon dioxide concentration over Svalbard at Zeppelin, which has crossed for already 400 ppm. It happened about 3 years back, which is almost mimicking what is happening in Hawaii. So now, what happens is that what could be the external forcing function, whether it's internal or external? What is the one which is driving the Arctic climate variabilities other than the so-called greenhouse gas emissions? First one, sea ice has to be removed. What will happen? Suppose, how do you remove the sea ice? The fundamental thing is definitely there has to be an atmospheric circulation pattern. Warm and moist air coming from elsewhere. It can just actually kind of cannibalize on the sea ice and other things, remove it from the surface. So that's one thing. And that will also lead to increased downwelling of the long wave radiation. Yeah, there was a lot of discussion actually a couple of years back, 2 years back actually, in 2016 we had, 2016 January, was a particularly warm period in the Arctic. It is anomalously warm for that time of the year. So one of the fundamental things which have been said is that before that, a month before that, we had a storm Frank from the Atlantic. That would have been responsible for the transportation of warm and moist air into the Arctic, which would have led to a warming Arctic, and in fact, a consequence of that will be the removal of sea ice from the top. But again, once you have the removal of sea ice from the top also, it can act also the other way around also, because removal of sea ice also results in increased temperature in the atmosphere, which will again lead to increased atmospheric circulation, more heat is generated. So it's a kind of a cannibalizing vicious circle, one feeds into another, and the net result of course is that sea ice is getting removed. Second thing, oceanic variable, so it should have a number 2, not 3 anyway. Okay, so this is a simulation, model simulation said that it's almost nearly about half of the sea ice trend which you are seeing in the Arctic is the result of oceanic variabilities. There is a multi-decadal Atlantic multi-decadal oscillation, which is actually a surface expression on the sea surface temperatures over the Atlantic, North Atlantic mainly. So if there is a variability of the order, that's one way where the heat can be transported from the mid-latitudes to the Arctic, and that can be responsible for the removal of the sea ice as well as on the warming of the Arctic. So that's the second number. Number 3, a coupling of the three. When you are saying about the atmosphere can be responsible, ocean can be responsible, what about a combination of the two? That can also lead to anomalous warming in the Arctic and leading to a situation wherein most of the ice can be removed from there. So multi-decadal variations in the North Atlantic oscillation, what it means is basically, if there's a pressure difference, sea level pressure difference between the north and mid latitudes as well as the polar gyres up there, what will happen is that increased transportation of the warm temperature, Arctic warms, from the Labrador areas up to the north. And that can be carried in 2 ways, either to the atmosphere or to the ocean. Again, the net result is the same, warming can set in, sea ice can get disturbed. So this is one of the latest papers which came about this coupling between the atmosphere and the ocean leading to sea ice extent. Yes, I'm almost there. Now I'm coming to the last few slides, and I'll just quickly run through it. What makes Svalbard important? I said the Svalbard is the area. I'll leave you with a couple of slides on this one. This is again an anomaly, the global anomaly, September temperature, surface temperature of the globe. What you see are the contours in degrees Celsius. You see 2 patches. The blue patch which says that Antarctic is the coldest part in September. Of course, no surprise there. What is surprising is the Arctic, and especially Svalbard. Compared to seasonal norms, the warmest place on Earth in September 2017 was Svalbard. The temperature difference was order of 4.64 degrees warmer than the last 30 years. So that is the one which drives home the point that Svalbard is the area where several things are happening. So I think I will just skip this one because Ariel had been so kind enough that he has already explained about the circulation pattern. The most important thing is that you have got the circulation pattern where the warm saline waters are being transported northwards, and they actually try to kind of mix with the cold waters again which are going northward. So there is a frontal instability in this area on the western Svalbard. When there's a frontal instability like this, I definitely can imagine a situation where there will be mixing of the waters, what results as what we call as the transformed Atlantic water, which is the one which is affecting the ecosystem dynamics in the different fjords of the Arctic. Okay, what's here? Yeah, there's no seconds. Yeah, looking at the fjords and I think because of the positive time, I'll just quickly go through only two fjords. We have got several fjords on the western side of Svalbard, which all of them respond to the so-called climate variability in different ways. We have got one on the southern side, Hansen, which is actually said to be almost an Arctic fjord, in the sense that most of the water which is coming into that there is the cold and fresh waters. So it's actually acting as an Arctic fjord. Whereas the good old Nielsen, the area where you've got the Kongsfjord and about which a lot of people have been working on, it is something which starts out as an Arctic fjord in the winter. It's no longer Arctic fjord because the recent studies point that it's acting mostly as an Atlantic fjord only. A lot of warm and saline fresh waters entering there, which is affecting the ecosystem dynamics in this area. So this is a figure which I have taken from two of my colleagues from NCAOR who published it recently. It shows about the variability in the temperature over the entire Svalbard, the entire Kongsfjord area. Compared to, so you have got two averages, 2005 to 10. This is the one, what you see in black, and what you see in brown is the 2011-13 average. It shows that the Kongsfjord has been warming almost until right from the bottom. It's the Atlantic water as well as surface waters are warming at a temperature differences of order of about 0.4 degrees Celsius. So again, when you're comparing that with southern fjord, and for instance Hansen fjord, which is published by Prominska and others a couple of months back, it shows that there is a perceptible difference between the southern fjord and the northern fjord. So the northern fjord, the way it is active to the climate variability is much different. Active to the incursions of the warm saline water is different as compared to the fjords on the southern side. The northern fjords are much more warmer. The average temperature in the Kongsfjord, for instance, is almost about an order of 1 degree Celsius warmer, and its salinity is also higher because there is more influx of the Atlantic waters into the Kongsfjord as compared to southern fjords. So now, these are some of the things. Again, Ariel has been he has also given a glimpse of what exactly, when we talk about the climate, we always talk about the humans, so how it is going to affect we people, but it's affecting the ecosystem there, the Arctic also. There have been several studies that have been carried out. Reindeers are shrinking, both in size, because basically what happens is there's something called rain over snow effect. When you have got rain, what happens, the liquid precipitation, it freezes over a size. It blocks away the food for the people. Otherwise, it would be just regular snowing and other things. You definitely come summer, these animals, they get the food for them. So basically, it's a number of, the reindeers are shrinking both in size as well as in numbers. And Svalbard ptarmigan is actually, there's a decrease in population across the board along all ecosystems there in the Svalbard area. And the most important thing is, this is a picture which made headline news in India also, and it was down south in Hyderabad also. It came in the newspaper. And the picture talks a lot. It shows a bunch of polar bears feeding on a dead whale in the Russian Arctic area. So why should it feed? Because basically most of the polar bears, they depend on the sea ice for the transportation. For this, they depend on seals. When seals diminish, they have to sort of cannibalize whatever they have got. So I'll leave it with these things. Exactly, that's why I left my concluding thoughts blank, because I knew that I was running out of time. So I would leave it with you thinking that the most important bottom line which I want to tell is that there are things which are happening in Svalbard, and we are not seeing the last of what is happening, and that it's better to be warned rather than feel sorry tomorrow saying that, hey, look here, you could have done much better. Thank you very much.